Hello guys at welcome back sa ating channel. This is the part 2 or the solving part for analysis and design for compression strength or the column strength design. So given dito, yung ating example number 1. Design a square-tied column to support an axial dead load of 500 kN and live load of 700 kN. Assume F prime C 24 megapascal, Fy 415 megapascal, 36 mm diameter main bar, and steel ratio of 1.5%. Determine how many main rebars will be used and the required spacing of the ties. Okay, so ito po yung ating column for example, and then we have here the P sub 0 acting at the centroid of our column. Again, recall natin that the P sub 0 is equal to the strength of the concrete plus the strength of the steel, which is equal to 0.85 F prime C quantity area gross minus area steel plus Fy AST. Okay. So, ang tanong sa atin sa number 1 is how many main rebars will be used? Meaning to say, kailangan natin dito ng area ng steel para ma-solve natin kung ilang bilang ng 36 mm diameter rebar ang magagamit. Okay, using our formula P sub 0 here, we can actually solve for the value of AS. However, madaming unknown dito sa ating first formula. The P sub 0 itself is unknown. Area gross is also unknown. Ang sinabi lang sa atin dito, we have a square-tied column. That's the only clue na meron tayo. Okay? However, meron din naman tayong binigay dito, no, na steel ratio equal to 1.5%. Let's utilize first the steel ratio here. Recall that steel ratio for column is equal to area of the steel divided by the gross cross-sectional area. Okay, we can actually play along with this formula. Gusto nating malaman ang magiging area ng bakal natin. Okay? To do that, simple lang naman. We substitute here the steel ratio which is 1.5% and this is equal to the area of the steel divided by the gross cross-sectional area. We can actually solve directly for the value of the area of steel. Gawin lang natin dito na ang area gross ay equal to area steel or in terms of the area steel. Area gross here is actually equal to area steel divided by 1.5%. This will be our first equation. Now, substituting AG dito sa ating first formula, wala pa tayong mapapala kasi kailangan natin ng P sub 0. Okay? Solve natin ang P sub 0 by calculating first the ultimate load acting at our column. Given sa atin ang mga service loads na dead load and live load, 500 by 700 respectively. So, we calculate first the ultimate load for this column. PU for NSCP 2015 is 1.2 dead load plus 1.6 live load. This will be our combination. Okay, PU now is equal to 1.2500 plus 1.6 700. Okay, now we can solve for the value of PU. PU here is actually equal to 1.2 500 plus 1.6 of 700. We get 1,720. 1,720 kilonewton. Okay? So, hindi pa to yung PO. Take note, however, that PU is equal to phi PN. Now, what is the reduction factor for a tied column? Recall that the phi for tied column is 0.65. Okay? Substitute lang natin yung 0.65 dito to get the value of PN. 1,720 is equal to 0.65 P nominal. Now, the P nominal is equal to Divide lang natin ito ng 0.65. And then we get 2646.15. 2646.15 kilonewton. Okay? And then, hindi pa rin ito yung ating P sub 0, pero malapit na tayo. We also take note that Pn is actually equal to, for tide column, ang multiplier natin or factor natin ay 0.8 P sub 0. Okay, again, the nominal for tide column is 0.8, the P sub 0. Pwede na natin kunin yung P sub 0 dito. 2646.15 is equal to 0.8 P sub 0. Okay, so wag na natin tong i-clear muna. Diretso na lang natin tong i-divide ng 0.8 to solve for P sub 0 para exact value ito. 3307.69. P sub 0 is 3307.69. Okay? Again, this is kilonewton. So, meron na tayong P sub 0 and then pwede na natin kunin ang area ng steel reinforcement para sa number 1. Okay? We substitute 3307.69 dito sa ating equation. Okay? But, take note that kailangan natin itong i-convert into Newton muna. 3307.69. To convert this to Newton, we multiply here 1,000. And then this is equal to 0.85. F prime C natin ay 24. The area gross here is AST over 1.5%. Okay? So gawin natin dito AST over 1.5% minus AST. Okay? And then we add. Okay? Fy is 415 times area steel. Okay, so isa na lang po yung unknown sa atin dito. And that is the area of the steel reinforcement. So we solve for it. Okay? So store ko lang muna ito para mas exact value. Alright? So recall natin yung A. Multiply tayo dito ng 1,000. Then equate this to 0.85. 0.85 nung 24. Okay, and then we multiply AST, that is now. Okay, gawin natin yan unknown. Divide this by 1.5%. Okay, and then minus unknown plus 415 times unknown x. Then we solve for the value of x. Okay, so we get area of steel 1885.15 mm square. 1885.15 mm square. Okay, rewrite lang natin dito. The area of the steel is equal to 1885.15 mm square. Okay? This is the area of the reinforcement. However, hindi pa to yung tanong. Ilang 36 mm daw ang magkakasya dito sa area ng steel natin. Now, to solve for the number of bars, okay? Number of bars is equal to this area divide this by the area of 1 36 mm rebar, and that is equal to pi over 4 36 square. Okay? So we solve. Ito yung na-solve natin na x. Divide this by pi over 4. Where is the pi here? Okay, so x divided by pi over 4 36 square. And this is equal to 1.85 pieces. Okay? 1.85 pieces. Right? So the number of bars is 1.85 pieces or approximately 2 pieces. Okay? Is this correct? Okay? Although ang sinasabi ng ating or yung nakuha natin ay 2 pieces, take note na merong sinabi si NSCP sa atin na for rectangular tied column, the minimum number of bars is 4 pieces. So this answer should be rounded off to 4 pieces. We cannot accept this as our final answer. So, the number of bars na tatanggapin natin must be 4 pieces. As per code, 4 ang dapat na meron tayo para sa rectangular tied column. So, this will be our answer for number 1. Okay, for number 2 naman dito, we are asked, what is the required spacing of the ties? Okay, so parang share lang din ito. However, since wala naman ditong binigay na value ng VU sa atin, hindi natin masosolve yung magiging value ng VS. So for this one, ang isolve na lang natin or ang i-check na lang natin what must be the maximum spacing of our ties. And then, we recall yung formula natin for the maximum spacing of the ties. So we're given here, okay, yung formula natin is for the maximum spacing is the least among 16 diameter the main bar, 48 diameter of the ties, and then the least dimension of the beam. So ito yung ating maximum spacing. Itong minimum spacing dito, this is the spacing of the main rebar reinforcement. Okay? So 16 dB, 48 dB, and the least dimension of the beam yung gagawin natin. Okay? So for the 16 dB, okay, yun ang unahin natin. For the maximum spacing, max spacing. Okay, first we have 16 diameter of the main bar, no? Capital B. So this is 16 times 36. And this is actually equal to 576. Okay? 16 times 36, check. Okay, 576 mm. Okay? 576 mm. Next, we get 48 diameter of the ties. Okay? 48 diameter of the ties. Okay. So, walang binigay sa atin dito na diameter nung ating tie reinforcement. However, okay, we use the 36 mm as our clue. Sinabi ng NSCP natin that for 32 mm and less, we use 10 mm ties or stirrup reinforcement. And then for 36 mm and greater, okay, we use 12 mm ties or stirrup reinforcement. Since 36 mm ang binigay dito, 12 mm ang dapat minimum natin na tie reinforcement. Okay? So we substitute here 12 mm. So we solve, no? 48 times 12. 48 times 12, this is actually equal to 576 din, no? So this is 48 times 12 is also 576 mm. Okay? 576 mm. Okay? And then for the third option, we solve for the least dimension of the beam. Wala ring sinabi dito kung ano yung minimum dimension ng beam na nakakabit dito sa ating column. And since wala namang nakastate sa ating problem, we assume na lang, no, na if ever man may maikabit dito na beam, yung minimum width niya ay same dun sa dimension ng ating column. Okay, yung column natin ay square tied column. So, isolve natin muna yung area nitong ating tied column. So, balikan natin yung nasolve natin na AG equal to AST divided by 1.5%. Given naman na dito yung AST dito. So, isolve na natin dito, no? Ano yung magiging value kaya nitong ating gross cross-sectional area? That is 1885.15 divided by 1.5%. Okay? 1885.15 divide this by 1.5%. Okay? And this is equal to 125,676.67. 125 125,676.67 mm square. Okay, take note that the given problem is square tiled column daw. So this area here, equate lang natin to sa S square. Okay, to solve for the side, no? S square now is equal to, okay, or dito na lang siguro sa taas. S square is actually equal to 125,676.67 mm square. Now, yung side natin, no, for our column is equal to, okay, square root lang yan nung ating answer kanina. And that is 355 or 354.51. 354.51. Okay? Mm. Okay? Since side ang pinag-uusapan natin dito, we round this to 355 mm. Assume natin na ito rin yung minimum width na nakakabit doon sa ating column. Okay? So, the answer here now is, or the list dimension natin is equal to S. And S is actually equal to 355 mm. Okay? Then take note, no, if we're choosing for the maximum spacing of the ties, we use the least among the three. So, ang mag-govern dito na spacing natin or the maximum spacing ng ties ay yung 355 mm. So, we can now actually box this as our final answer. Okay? So, yung maximum lang yung na-solve natin, no? Wala kasing sinabi dito na walang given na VU. Okay, and we can actually solve for the VS, no? Parang yung beam lang din, actually. Okay, so this is the solution for example number 1. Okay, example number 2. A circular column spirally reinforced is to support an ultimate load of 3,300 kN. Use F prime C 24 megapascal, Fy 345 MPa, use 10 mm spiral reinforcement and steel ratio of 2.5%. Determine the required number of 28 mm bar diameter and what is the required pitch of the spiral. So just like in number 1, very similar naman yung tanong natin dito, but this time we're given here a circular column that is spirally reinforced. Okay? So to solve for the number of 28 mm bars, we need the area of the steel first. Okay? So given dito yung PU, just like our step kanina, no? So solve muna natin dito what must be the value of the P sub 0. Okay? So PU here is actually equal to phi P sub N. Okay? So take note that this is now spiral. Okay? So ang phi na gagamitin natin for spiral, this is now 0.75. Kanina 0.65 for tide, this time 0.75 naman na. So this is 3,300 is equal to 0.75 P sub N. Okay, and then our P sub N here must be equal to, okay, 3,300 divided by 0.75. Okay, and this is equal to 4,400 kilonewton. Okay, 4,400 kilonewton. Right. Then next, after this one, we solve for the P sub 0. Okay. Now, our factor naman na dito is now 0.85. 0.85. Kanina 0.84 tied, this time naman 0.85 na. P sub 0. Okay, so 4,400 is equal to 0.85 P sub 0. And our P sub 0 here is equal to 0.85. Right. 5176.47. 5176.47. Okay? Kilo Newton. Alright. So, gawin naman na natin this time. Okay, equate na natin ito, no? P sub 0 is equal to 0.85 F prime C quantity gross minus area of the steel plus Fy area of the steel. Again, wala kang mapapala dito, no? But we know that the raw or the steel ratio is equal to area of the steel divided by the gross cross-sectional area. Then, we make this area gross muna, no? In terms of area steel. Area steel divided by 2.5%. Okay? So, we substitute everything dun sa ating P sub 0. 5176.47. Make this in Newton is equal to 0.85. F prime C is 24. Area gross is AST over 2.5% minus area of the steel plus Fy natin is 345 area of the steel. Okay? So, we can now solve for the value of the area steel. Okay? So, 5176. Substitute lang natin lahat. 5176.47 times 10 raised to 3 equal to 0.85, 24. Okay? Unknown. 2.5%. Less the area of the steel plus 345 area of the steel. We solve for the value of X. We solve 4538.37. 4538.37. 4538.37 mm square. Okay? Now we can solve for the number of bars. Number of bars is equal to area of the steel divided by pi over 4, 28 square. Okay? So this is now equal to, okay, the solved area equal to pi over 4, 28 square. Okay, 7.37. Alright, 7.37 pieces or approximately 8 pieces. Okay, so we can now box this as our final answer. Next, for the letter B, what is the required pitch of this spiral? Okay? So, para dito, kailangan muna natin isolve yung magiging minimum spiral steel ratio natin. Okay? So, we solve for the minimum spiral muna. That is 0.45 quantity area gross, area core, minus 1, F prime C, Fy T. Okay? So, the raw minimum, okay, for letter B, the steel ratio minimum for spiral is 0.45 area gross of the concrete column, area core minus 1 F prime C over Fy. Alright? Okay, or Fyt rather. Okay? Fy of the transverse reinforcement. Fyt. Okay, so meron na tayong gross cross-sectional area. Makukuha na natin yan actually using this formula. AST divided by 2.5%. Now, what about yung area ng concrete core natin? Okay, so we have here the figure, no? Yung diameter core is actually the diameter of the outside tie reinforcement. Okay, so given here our diameter of the concrete, okay, so ito yung outside natin, tapos ito yung ating yung red dito, this is our tie, no, or the spiral reinforcement. Okay, and we have here clear cover actually, no, so the value of DC is simply equal to, or this is actually the diameter of the core na, yung DC dito. The diameter of the core here is actually the diameter of the column less 2 concrete cover. Alright? So, dito sa taas at baba, meron kasi tayo ditong concrete cover. And for the column, the minimum concrete cover natin, ang gagamitin natin ay 40 mm. Okay? So, the diameter of the column, wala pa tayong value niyan. We solve first the value of the gross cross-sectional area. Alright? So, balikan natin yung equation natin dito. Area gross is equal to AST divided by 2.5%. Okay? We can actually solve. Okay? So, the area of the steel, that is X. Tama? Divide this by 2.5%. Okay? And the value of the AG is now 181,534. 181,534. 181,534.98 mm square. Right? So, this is now 98 mm square. Meron na tayo ditong gross cross-sectional area. Alright? So, ngayon, gusto nating malaman yung magiging diameter nitong concrete column natin. So, para makuha natin yon, kunin natin ano ba ang area ng column natin. The area of our column that is equal to, okay, area column is equal to area gross. The area of the column is equal to pi over 4 diameter of the column square, divide this, equate this to 181,534.98. Okay? 181,534.98 mm square. So, we can actually solve here. Okay? We can now solve here the diameter of our concrete. Okay? Concrete column. So, this is equal to, store na lang muna natin ito sa A. Ayan, para stored value lahat. Pi over 4 diameter square is equal to the stored value A. Okay? So, we calculate what is the diameter. 480.77. 480.77. 480.77 mm. Okay? So, ayaw naman natin yung may butal, no? So, we round this to, pinaka-nearest na ay 485 mm. Okay? So, by 5 mm yung rounding natin. So, this will be our diameter of the concrete. Ito na yung i-adapt natin na area or diameter ng ating concrete column. Okay? So, we can now actually solve for the diameter of the concrete core, and that is equal to 485 less 2 cover. That is 40 mm. Now, the diameter of the concrete core is equal to 485 minus twice nung 40. Okay? So, that is 405 mm. 405 mm. This is our diameter of the concrete core. And then, of course, yung area naman ng concrete core natin, okay, yun yung ACH natin, that is simply pi over 4 diameter of the concrete core square. Okay? So, pi over 4 pi over 4 405 square. Okay? Oops. So, this is equal to, in terms of pi na lang siguro, no? Better. 405 square divided by 4. Para mas okay. And 41,006.25. 41,006.25. 41,006.25 pi. Alright? So, ito yung ating area of the concrete core. Okay. Now, pwede na natin kunin yung raw minimum for spiral. Okay. Dahil ni-round natin yung diameter ng ating column, yung AG natin dito is i-adjust na rin natin. So, kunin natin yung adjusted area nito para adjusted lahat, no? We cannot use 181,534.98 kasi ang ibibigay na diameter nun ay 480. Since we rounded our diameter, we must also round our area gross. Okay? So, we solve for the new AG. Okay? AG now here is pi over 4. The new diameter is 485. And then we square this one. Okay? So, AG here is equal to, okay, similarly, in terms of pi din natin ito, 485 squared divided by 4. Okay, so we get 58,806.25. 58,806.25 pi. Alright? So, ito na yung bago nating AG. Okay, we can now solve for the raw S minimum. Okay? Raw S minimum is now equal to 0.45 times 58,806.25 pi over ACH natin ay 41,006.25 pi less 1 times F prime C natin ay 24 and then FYT. Since walang binigay na FYT, we use the FY as well. Okay? FYT is now equal to FY. So, F prime C natin 24 divided by 345. F prime C 24 divided by 345. Okay? The raw S minimum now is equal to 0.45 quantity. And so, magka-cancel na yung pi dito. 58,806.25 divided by 41,006.25 minus 1 times quantity. F prime C natin, 24 divided by 345. Okay? So, the raw minimum natin, store natin ito somewhere, siguro sa B na lang, 0.0135. 0.0135. 0.0135. Oops, 135 mm. Okay? 135 or walang unit pala, no? Still ratio. So, i-continuous lang natin yan. Naka-store siya sa ating B. Okay? Now, this is our minimum still ratio for spiral. Now, yung na-solve natin na minimum, i-equate lang natin yan dito sa actual still ratio for our spiral, no? Actual still ratio for spiral is equal to 4AS diameter core minus diameter of the spiral S DC square. Yung AS dito ay parang AV lang din nung ating shear reinforcement before, no? So, equate lang natin everything dito. 4AS DC minus, okay, ito po. So, i-copy na lang natin siguro ito. Then, we paste it dito sa ating, ayan, para meron tayong basis. right? So we equate everything here. Okay? So diretso na natin, no? 0.0135 is now equal to 4. Again, yung AS dito ay area nung spiral reinforcement, no? So that is pi over 4. Ang sinabi na diameter ay 10 mm. Alright? So pi over 4, 10 square. Okay, and then the diameter of the core, we solved 405 kanina, minus diameter of the core is 10 mm, or the spiral rather. Then spacing is unknown. Tapos 405 square. Alright? So ang unknown sa atin dito ay yung S lang dito. So finally, we can now solve for the value of S. Okay? So yung stored value natin for B, okay? B is equal to quantity 4. Okay, magka-cancel na yung 4 siguro dito. Pi na lang natin diretso. Okay? Pi 10 square. Tapos 405 less 10. Okay, and then this is the value of X, unknown, 405 square. Okay? We can now solve for the value of S. Okay? So the value of S is 55.68. 55.68 mm. Since we're talking about spacing, we must round this down, no? I-round na natin ito sa exact 55 mm na. Okay, mas dikit-dikit, mas safe. Okay, so is this the final spacing na natin? We check first kung pasok ito sa ating maximum spacing for spiral. Again, ang maximum spacing natin para sa spiral ay 75 mm, or yung pitch natin rather. Maximum spacing or maximum pitch here is 75 mm. Okay? So, yung 55 mm na na-solve natin is actually pwedeng-pwede. Pasok pa siya. Hindi siya lumagpas sa maximum natin. Therefore, we can now say na yung answer natin ay 55 mm. No? So, this is our solution for number 2. Okay? Okay, last item. Example number 3. A 500 by 500 mm composite column is reinforced with 825 mm diameter rebar and W14 by 53 wide flange as shown. Calculate the live load that the column can carry assuming that the applied dead load is 950 kN. Use F'C 21 megapascal, Fy 276, and structural steel Fy is equal to 248 megapascal. Okay? So, again, first solution natin dito is we calculate for the PU. No? Kaya lang, yung PU dito ay hindi natin basta-basta masosolve dahil yung mismong live load ay unknown. Okay? So, yun lang yung magiging working equation natin for now. Okay? So, PU is actually equal to, again, this is 1.2 of the dead plus 1.6 of the live load. Again, wala tayong mapapala sa PU muna dahil nga dead load lang ang given and live load is also unknown. Okay? So, we know that the other formula for PU is actually equal to phi of the nominal. Tama? Okay? And then, we expand this formula as well. Take note that Pn is equal to 0.8 P sub 0 for tied column. Okay? Paano tayo nakakasiguro na tied column ito? Because of the shape of the column. It is a rectangular or square column. Therefore, automatically, this is tied column. No? So, 0.8 po yung ating P sub n dito. Okay? Or yung ating factor. Now, Ano naman yung magiging reduction factor natin dito? For tied column, this is 0.65. Okay? So, PU now is equal to, again, yung reduction natin ay 0.65 times yung PN natin na 0.8 P sub 0. Okay? So, we simplify muna siguro itong 0.65 and 0.8. So, what is 65% of 0.8? That is 12 over, or 0.52. Okay? This is now 0.52 of P sub 0. Expand na rin natin diretso ang P sub 0. Dahil meron na tayo ditong structural steel, dadagdagan natin ito ng FYASX. Okay? So, our formula is 0.85. F prime C natin is 21 megapascal. Tapos, yung area gross natin, that is 500 by 500. Okay? So, that is square na natin. Less area of the steel. Okay? Area of the steel. So, that is equal to, okay, 8 pi over 4, 25 square. Okay? Minus, okay, by the way, edit natin yung formula natin. Dahil meron din pala tayo ditong structural steel, ilas din pala dapat natin, no? Yung magiging area occupied by the steel, no? Or structural steel natin. And this is minus ASX natin, 10,064 mm square. Okay? Paki-edit na lang yung ating formula. This is 10,064. Kailangan i-minus din natin ito, no? Dahil butas, occupied, no? Ng mga structural steel and rebar. Next, add natin dito yung FYAST natin. That is 276 for the rebar times area of the steel. That is 8 pi over 4, 25 square. Okay? And then, i-add din natin yung structural steel element. That is FY, yung capital, 248. Multiply that by the area, 10,064. Ayan, 10,064 mm square. Okay? Again, this is the area for our concrete. This is the strength of our rebar, and then this is the strength of our structural steel element. Now, we simplify this all. We can now get the value of PU. Okay? So, solve muna natin yung mga nasa loob siguro. Okay? Isa-isayin natin. This is 0.85 times 21 times yung nasa loob. This is 500 square. Okay, that is square minus, okay, 8 pi over 4 or magiging 2 pi na lang ito. 2 pi, 25 square, okay, minus 10,064. Okay, so this is for the concrete, okay, plus Fy natin times 2 pi 25 square. Okay, for the rebar. Then we add also 248 times 10,064. Okay? So ito yung mga nasa bracket natin. Don't forget the 0.52. Multiply this all by 0.52. Okay? And then we divide this by 1,000 to make it kilonewton. Alright? So, ang PU natin ay 4,052.09. 4,052.09. Kilonewton. Okay? So, meron na tayong PU dito. Okay? Ang tanong lang sa atin dito, what is the live load dito? So, PU or 4,052.09 is equal to 1.2 of our dead load, that is 950 kilonewton, plus 1.6 of the live load, which is actually the unknown. Okay? So, store na lang natin ito sa A. Okay? So, A is equal to 1.2, 950 plus 1.6 unknown. Okay? So, solving for the live load, 1820.06. 1820.06 kilonewton. And this is actually our final answer. Okay? So, this is the solution for number 3. Problems 1 to 3 are all short column and concentrically loaded. Okay? So, next video, pag-usapan naman natin yung long column and also yung mga eccentrically loaded column.